So what do code quality tools actually do? How are they different from security tools like static application security testing? How are they different from tools like a linter? And where do we put it in our development lifecycle? Well, you will never believe it, but we're going to be talking about all of that in this video. My name is Mackenzie Jackson, and you're watching Tool Time by Aikido Security. So as the name would suggest, code quality tools are there to check the quality of your code. But how exactly do they do this? Well, typically they're injected into the development lifecycle, usually kind of at the Git repository where a check is done, maybe through the CI/CD pipeline, or you may have some local tools that run as something like a Git hook that actually checks your code, makes sure it follows certain standards, there's certain procedures, and it makes sure to some degree that you don't have some security issues within it. Code quality really differences from a lot of other tools, in particular security tools, because a lot of what code quality does is undeterministic. What do I mean by that? Well, determinism is basically a yes or no answer. If something's determined, it's either yes or no, or in security, it passes or it fails. Code quality works a lot in the realm of nuance. And this makes it a very different tool, but it also means that there is a lot of crossover in some areas, like in security. To really understand code quality, I like to break it up into kind of 6 different categories of what it's looking for. I'm not going to list at all of the things under all of the categories that these have, but I kind of want to give you a general idea because it's going to help. So let's start off here in this security category. What is an example of a security issue that a code quality tool might find that a SAST tool, for example, won't? Well, one of them will be malicious code. Code that maybe is injected. So let's say a developer's GitHub account is compromised and they put malicious code into your application. Well, this is a very clear security risk, but why wouldn't a static application security tool find this? Well, malicious code can be actually quite hard to detect because unlike security issues, it's not deterministic. For example, let's say that you have this malware in there that's making calls to kind of random domains, but it's encoded in base 64. They're using all kinds of weird techniques to hide it, and it kind of just looks weird. Well, you can't really write security rules for that because there's legitimate reasons why you might want to have base 64 in your code. There are legitimate reasons why you may want to be calling external domains. However, when you add in code quality and a little bit of nuance and undeterminism in there, it's pretty obvious that this is weird, not supposed to be there, so therefore, high likelihood that it's malware. That is an area where code quality will find a security issue that a SAST tool won't. There are some areas in security where there's going to be crossover with other tools. For example, code quality will also be looking at things like what type of hashing algorithms or cryptographic algorithms are you using? Are they up to standard? This is something that a SAST tool will also look at. So there is crossover, but there's also going to be areas that are new. And most importantly, a code quality tool is not a replacement for security scanning that you're already doing. I want to be very clear on that point. Another category that code quality is going to be looking for is readability. And you guessed it, it's about how readable your code is. But this comes down to kind of concrete things like avoiding really deep nesting inside your files. So it's very difficult to understand. It may even be things like making sure that you're using comments to explain functions and classes as you go. A code quality tool can kind of enforce this and check for this. It can kind of be simple things like making sure your files aren't too long or that you're not using maybe multiple classes in a single file. And it even could be to do with kind of the debugging process and making sure that you handle your errors in catchbox so that people can actually understand errors that they're getting through. So all of these things come down to readability. There's a huge list. We're not going to go through them all, but you kind of get the idea. This in particular is very nuanced, or let's say undeterministic. Performance issues is again pretty self-explanatory, making sure you're not doing things like select star in SQL databases that are very big. This can really slow down your performance. Or just other obvious areas where performance is going to be affected, like big, long, nested loops that keep going, or functions that don't seem to have an end or do unnecessarily computational things. These are all performance issues that a code quality tool should check. The next category is maintainability. And a code quality tool might look for things like making sure that you favor composition over inheritance. Favoring composition is a design principle that basically means that you're favoring breaking things apart into smaller building blocks rather than continuously expanding on them, which is what inheritance is. This is a big area in maintainability. And then we get to kind of the 2 bug categories, bug risk and logic bugs. The reason why we kind of separate these two apart is that bug risk is kind of really looking at nuance and maybe the kind of languages that you're using or the operating system that it's going to run across. For example, a rule may be to ensure that your class and your file name match. Using different capitalization structures can break in a Linux operating system, for example. This is a bug risk, but it's not a logic bug. Another area may be to make sure that you're avoiding recursion without any depth protection. Recursion without any or proper depth limiting could result in stack overflows and result in some very nasty bugs and also some potential security issues down the line. And then you have things like logic bugs. And I guess like the easiest one to talk about a logic bug is that you are forgetting to remove your debugging code when it goes out to production. I laugh, but it actually happens so often where you kind of forget this. And this is kind of in the logic of your application. You've essentially may have put backdoors or intentional vulnerabilities in there for you to debug something, but actually it can be used in production against you. And that's definitely something that code quality will be looking for. So they're kind of the categories of code quality. I don't want to ham on about that. If you want to learn more in the links, I'll have a list of kind of a lot of different rules that code quality will be looking for. So now that we know kind of the categories of code quality, and we also know why it's not necessarily a security kind of tool or how it's different to security tools, another question you might have was, is code quality then a linter, or is linter kind of part of a code quality tool? They are kind of separate. Code quality tools will often include linting, but here's how you can separate them. A linter, think of it like a spell checker in a document, right? It's looking for syntax areas. It's making sure that everything is consistent, right? Whereas code quality is more like an editor. It's probably checking all of those grammatical things that the spell checker is, but they're also looking for tone. They're also looking for readability. They're also making sure that it fits the standards that you want to achieve. Now, there's something that I have been really looking forward to talking about in this video, and that, of course, is AI. But it's actually really cool when it comes to code quality. See, AI is changing the game in all of these developer tools, and especially in security tools. But there's a big difference between how AI is used in other security tools and how it's used in code quality. And that comes back to something we've already talked about called determinism. See, I mentioned that security tools should be deterministic. You want a pass or a fail when it comes to security. You don't want any of this wishy-wash around it. Well, when it comes to code quality, I'm sorry, but there's wishy-wash there, right? So there it is non-deterministic. And guess what? AI models and LLMs are also non-deterministic. Now, that means that they make terrible security scanners. If you put the same code into an LLM or an AI model, it may give you a different result because of the model temperature. It's non-determinism. Whereas with code quality, you want an area of nuance. For example, traditional code quality tools used to use a lot of rules and statistics. One of those statistics was how many comments that you had in your files versus how many functions or how long it is or other areas. And then it could spit out a number of like, yeah, we don't think there's enough comments in this. But it doesn't let you know like how good are the comments, how informative are they, and all of these different areas. Well, an AI model can actually look at that and give you all of that nuance, which is fantastic. So many of these areas where code quality has been really a struggle because of the amount of rules that you needed to make to cover all of these non-deterministic kind of results. Well, now we can introduce AI into it. And it also makes writing rules a whole bunch easier. So AI is a game changer in code quality, way more than it is in security when it comes to scanning. I know there's going to be a whole bunch of AI groupies in the comments of this, so I don't want to say that AI isn't amazing in security. It is, yeah, whatever. It's just really good at the scanning part for code quality in here. And it's really exciting if you're a nerd like me. I always like to have a look at a couple of different tools in these videos. I like to have a look mostly at an open source version and also at kind of a commercial tool to show the difference. So in this case, the open source tool that we're using is called PMD, which is a source code analyzer that is completely open source. What is great about this tool is that you can actually check out everything, including all the rules. So we're just going to use Java here, and there is an entire rule set for Java, and this will let you know of kind of what it's looking for. So this is a more traditional code quality tool. What we talked about is going to be using things like static rules to be able to detect code quality, but it will still be able to find a lot of things. So let's have a look. I have just a sample Java project open here, and we're going to run this against our application. in our code to see what it's going to find. So it's going to quickly run a check through all of our code that we have, and it's found a whole bunch of things that we need to improve. Now, if you're looking at the same screen I'm looking at, this isn't the most pretty tool that we're using. The information in it is all good, but it kind of leaves something there for its formatting. So you can see here, let's have a look at some of the comments. We have this product.java file, and here it's saying that, this statement, the control statement braces, this statement should have braces. That's one area that we're looking for here. So we can have quite a lot to actually kind of go through here. Now, obviously, because of how this is formatted, if I zoom out, it becomes a little bit more readable, for me at least, not necessarily for you watching. But you can kind of see what it's finding. Now, ideally, what we would do is we'd take these results in something like a JSON format that would put it into another tool so that we can visualize them and actually start to go through that. And that's definitely what I would recommend if you're going to be using a tool like this. Another way is that you could use this tool to actually have blocking checks in things like maybe a Git hook or in your CI/CD pipeline to make sure that everything follows the standards there. Now, because it's open source, you can write your own rules, which is pretty useful as well. But this isn't really how modern code quality works. So let's go ahead and take a look at Aikido. Now, obviously, I work for Aikido, so this isn't the only commercial tool, but it's obviously the one that I know best and how it works, so I can help explain it. So here we have in our activity log, this is kind of all the issues of code quality that were found in our repos and our pull request. So you can see here kind of an interesting mix of some security issues and some traditional code quality issues. So we have here kind of a NoSQL injection attack. This is one that you would expect also a SAST tool to be able to find. But then we also have some other types of issues here. So here we have this kind of hard-coded if true thing, which means that the else statement that's below it is kind of completely dead because you can never get to that. Here we have areas like removing debugging code. So here we have the console log, and we can kind of scroll down and see various different issues here. Keep lines at readable lengths. We have this like long scroll bar. With this comment, you can kind of see someone's been having fun. What I want to do is I really want to show you how powerful this can be. And hopefully it will blow your mind, because it blew my mind the first time I found this. So I'm going to give some examples of creating some rules for code quality. And these rules are going to get progressively mind-blowing, I promise you. Let's start off with something simple. So when I create a rule, I don't need to write any code. I can just describe what I want the rule to do, and that is enough. So for example, I'm going to write a rule that says detect any function or method where the logical or loop structures are kind of greater than 3 deep. I'll give some examples of what these are. And this should fail on something that kind of like looks very, very nested. So down here, I can actually automatically generate code based on this prompt where it can test it. But I can also paste in my own code. So I'm going to do that just so you don't think I'm cheating. So here we can see we have a deeply nested kind of code. And to the left is kind of what it should look like, if it was correct. And we can run our check to make sure it fails on this, right? And it has failed. And when we go to the next step, we just kind of add some more information. But that's it. We literally just wrote a code quality rule really, really simply. Now, this is fun, but you could write a traditional rule to cover this too, right? This isn't groundbreaking yet. Okay, I'm going to step it up a little bit. Now I'm going to write a rule that basically says that I want you to detect any code that has ambiguous, poor, or non-existent comments. This is something that would be impossible or very, very, very difficult to write a rule for. You could do it based on like the number of comments per number of lines of code, but you couldn't tell if something's a good comment or a bad comment. So let's again here add in some code to test this. So here we have a couple of comments and they're ambiguous. They're not very good. And here we have some detailed comments. And if we check this, we can actually see that, yeah, this passes that code quality check. Now we're going to get really cool. So what I'm going to do is I'm going to write a rule. And that rule is going to be detect contradictory or impossible logic. Now, logic is something that was impossible to detect with deterministic tools. How do you write a rule for logic, right? You can't. But now you can, thanks to this. So what I have is I have some code here, and basically this code is pretty simple. It's just a pretty simple example, but you can imagine how powerful this could be. Is that I have here that if a score here is greater than 100, then we go into the next block. But we contradict that by saying if the score is like under 50. Well, it's impossible for it to get under 50 because to get to this block, it has to be over 100, right? This is an example of impossible logic. We've got a working version to the left, an unworking version to the right, and we're going to check that this finds it, and blammo, as if I already knew before I made this video, it detected it correctly. This is just so cool. It is just so cool that we can write out code quality rules like this. It just blows my mind. So anyway, I could write rules all day, and you can too. You can actually sign up for Aikido for free and check this out. Write some rules yourself. Go wild. Let me know in the comments what's the weirdest rule that you've written. And then I have to kind of move on to the next video because I've already talked for way too long.